In this lab, we have the North America head office on the left, with a firewall host name of FTDNA, and a remote Europe branch on the right, with a firewall host name of FTDEU. Both firewalls are already registered to the FMC at the HQ site. They both utilize basic outbound dynamic net policy, have access control policies, and 2 default routes. The backup default route has a high metric. We are going to create 2 site-to-site VPN tunnels. Technically, we can create 4 tunnels, but it is not necessary. In FMC, we can see the 2 registered firewall. Click Devices, VPN Site-to-Site. First we need set a topology name. Check Routed-Based VTI, keep point-to-point topology. Select Node ABE Firewall, which is FTDNA, then click the plus sign to create the primary VTI. Modify VTI interface name. Verify outside one interface and IP address are selected as tunnel source. Create a new security zone called S2S VPN zone. Dedicated VPN zone is highly suggested, so we don't need create identity net. Verify the auto-filled tunnel interface IP address, which has /30 network mask. Click OK to complete the first VTI interface. Click Add Backup VTI to expand Backup VTI section. Click plus sign to create Backup VTI interface. Configure VTI interface name. Select outside 2 interface and its IP address as tunnel source. Add VTI to S2S VPN zone. Verify and accept the auto-filled VTI interface IP. After complete Node A setup, let's continue Node B configuration. First we configure the primary VTI interface same. Select outside one as tunnel source. Make sure the correct outside one interface IP is selected. Assign backup VTI to the S2S VPN zone. Set a meaningful interface name. Set the correct tunnel IP address. Add a backup VTI source from outside 2 interface. Configure VTI interface name, zone, tunnel source, and VTI IP address. In this lab, we use default IKE and IPsec settings. Note the default IKE Keep Alive (DPD) settings. These values determine how quickly the VPN can fail over to the backup VPN when the primary ISP fails. After VPN configuration is complete, you will see a single VPN topology. By expanding this view, you can observe the 2 redundant VPN tunnels. The amber status indicate that the VPN tunnels are currently down because we haven't deployed the change yet. Let's proceed with deploying the change. We haven't configured static routes and ACP rules yet, but VPN should come up without them as long as VPN settings are correct. Deployment is completed. Let's check the status of the VPN tunnels to ensure everything is working as expected. After clicking refresh, we now see VPN tunnels are green, indicating that they are active and functioning correctly. We can also check VPN tunnels from Overview section to get a comprehensive view of their status and ensure everything is functioning smoothly. CLI details can provide useful information without the need to SSH into the firewall. This can be a more efficient way to quickly verify configurations, check statuses, and troubleshoot issues. Now let's add the missing static routes and ACP rules. Add the primary route to peer subnet. Add backup route to peer subnet with higher metric. Add the primary and backup static routes on HQ firewall. Now add bidirectional ACP rules on both HQ and branch firewalls. We also added ACP rules on NA firewall and successfully deployed the change. Let's do a ping test cross VPN tunnel. Ping is working. Let's navigate to the VPN overview to examine more details and ensure everything is functioning as expected. Keep in mind, the two route-based VPN tunnels are always up. It is the routing that determines which tunnel processes traffic. When the primary ISP fails, the VTI tunnel interface will go down, the primary route will be removed from the routing table, and the backup route to the peer network will become active. Once the primary ISP is restored, traffic will revert to the primary tunnel. Alternatively, we can set up SLA or path monitoring to facilitate VPN failover. Thank you for your watching. Please leave your comments.